Hello and welcome, my dear students and my viewers, to my channel Mathematics Made Easy. And a new alert for all of you about our Instagram account. So, our official Instagram account is on the name Teacher Miss Ruchika, and you can follow the link in the description box to follow me on Instagram by scanning the QR code. Another news alert for our channel, we have now an official Facebook page. Again, the link will be provided in the description box. Please connect to us there, like our Facebook page. Let's now start with part 2 of our lesson independent and dependent events. In the last video, we have looked at the differences between independent and dependent events. And in the session today, we will learn how to compute the probabilities of these kind of events and to further solve important problems on the topic of independent and dependent events. So let's get started. Revise the key concept we had seen in the last video on independent and dependent events. When we talk about the probabilities of independent events, so we are having two independent events here, then the probability that these events both occur together. Okay, so this is the probability that we are trying to find will be the product of the two individual probabilities of these two events. So this is the formula that we will be using. So simply just to say that two independent events are occurring together. If we need to find that probability, remember, and here is representing your intersection. So that's why we could also replace this formula with probability of A intersection B. Okay, so let's do the example one now. So I will read the question for you. A coin is tossed and a six-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the die. So I want you to observe, your students, that there are two events which are taking place in this question. Let me highlight them. The first one is the coin being tossed. This is event A. And the second one is the die is being rolled. So I want you to think about these two events A and B, whether they are independent or dependent. Because once we decide on that, we'll be able to use the correct formula. Now, because these are two different events, one is a coin which is being tossed, second is a die which is being rolled. So they are going to be definitely independent events, and therefore we can use the formula we saw on the previous slide, where the probability of A intersection B is the product of the probabilities. So let's calculate the individual probabilities and multiply them to get our answer here. So the probability that you will get a head on the coin is definitely 50% or 1 by 2. Probability that you will get a six-sided die, you will get a number 3 is 1 out of 6 options possible. So 1 by 2 multiplied with 1 by 6, that would give you 1 by 12 as the final answer. Now you can convert this fraction into percentage as well, but then the method to solve would be similar. Let's take another example here. This is a card problem, and a card is chosen at random from a deck of 52 cards. You have to find the probability that if you are drawing a card and then you're replacing it back and then taking out a second card. So observe the important word here, that is replacement. So here the replacement is going to happen. So definitely the probability will not get affected for the second draw, and hence this will be a question on independent events. Now what is the probability that we need to find here? We need to find the probability of choosing a jack and then a number 8. So this is the combined probability. Since these are independent events, we will calculate individual probability and multiply. Now in a pack of, or in a deck of 52 cards, there are 4 jack cards that are possible. So 4 out of 52 will be the first probability, and similarly there can be 4 numbers of 8. One from different set or different suit of the cards. So 4 over 52 multiplied with 4 over 52, that would give you your answer. You can simplify and it will come out to be 1 divided by 169 as the final one. Another example, this is on the probability jar. So the jar is having different colored marbles, 3 red, 5 green, 2 blue and 6 yellow. So if you want, you can draw a jar here, a rough jar, and put down the different colored marbles. So 3 of red, 5 of green, 2 of blue and 6 of yellow. So you can just add them up and you will get the total number of marbles. And then here in this question we have to find the probability that we are first choosing a green marble followed by a yellow marble. And remember, again, with replacement is the question, so it will be independent events. Now the probability to get a green is any one out of these 5 can come, so 5 over the total, and I'm sure you have added to get 16 here. And the probability for yellow, so yellow are 6, it's going to be 6 over 16. So we just multiply these two to get 15 divided by 128 as our answer. Let's now come to the second key concept for today, where we'll be talking about finding the probability of dependent events. So I'm sure you will recall from the previous session what are dependent events, and here the probability that two dependent events are going to both occur together is very similar to the concept of independent. Here also you are taking the product of the two probabilities, but the only difference here, which is very important, is that in this case when you're taking the product of the two dependent events, you're also considering the fact that the product of the probability for the first event is occurred, and then the second event is occurring after the first event has already occurred. So this probability B given A is calculated after the first event, which is A, has already happened. So that is the major difference for the dependent events and calculating their probability. I hope you can recall from the previous class that here this probability, I will write down it again for you so that you can remember, is the probability of event B given event A already occurred. And if you remember from my previous class, I had given a name, specific name for this probability, and that name is conditional probability. So in simple words, conditional probability is having a condition attached to it. So here the condition is that event B is occurring after event A has already occurred. So this is conditional probability. Let's see how we can apply this formula using conditional probability and calculate the probability of dependent event. Okay, so I'll read the example for you. In this example, there is a jar. I'm highlighting few things here. The jar has 3 red, 5 green, 2 blue and 6 yellow marbles. So total, you can just add them to get the total number, and then a marble is chosen from this jar. After that, a second marble is chosen without replacing. So this is the most important word in the word problem. This question is on without replacement, and that tells you that because it is without replacement, this is a question on dependent probability. Okay, so when we are doing the second draw, when we are trying to take out the second marble, after the first has been taken as green, then we are second marble that we're taking here is yellow. In that case, we are considering the conditional probability. So because these are dependent, again, probability of A intersection B, that is the probability of choosing a green followed by yellow, is equal to the probability of green multiplied with probability of yellow, given that the first marble has been drawn as green. Okay, so let me draw the marble, the jar here, and roughly draw the marbles. So 3 red, 5 green, 2 blue and 6 yellow. So just add them up, total is 16. So in the first draw, when we are having green, there are 5 green, so 5 divided by 16 would be the probability, nice and easy. For the second one, once we have the conditional probability, we have to see that, okay, one green has been taken out already. We are not replacing it back. So definitely the sample space will get affected. The outcomes will definitely get affected. And out of this 16, one is removed. So 15 are left. So the total would be 15 in this case. And the second marble, we want it to be yellow. So how many yellow marbles are there? 6. So any one out of the 6 can come out. So 6 divided by 15. This is how the sample space has got reduced, and you have to now just multiply and simplify to get your final answer for the probability, which is 1 over 80. Just to make the concept of dependent probability and conditional probability more clear to you, let's take another example. Here we have an aquarium, and this aquarium has 6 male goldfish and 4 female goldfish. Now you are randomly selecting a fish from this tank and you are not putting that fish back once you are selecting. So it is without replacement and therefore it's a question on dependent probability. Now when you are selecting the second fish, you are again doing that randomly and the question says find the probability that the both fishes are male. That means in the first draw also you get the male fish, in the second draw also you get the male fish. Very, very easy. Let's draw a rough diagram. 6 male fish, 4 female. So total is 10. First draw, you want the male fish. That's the first probability. So 6 over 10, pretty easy. Because you're not replacing back, the total sample space would reduce by 1. So it will be 9 fishes left after the first male fish has been drawn out. And then one male fish is already gone. So 6 minus 1 would give you 5. So 5 divided by 9 will be the conditional probability in the second row. So just multiply them, simplify, and your final answer would be 1 over 3. Okay, time to test yourself. Please check yourself, check your progress. This is a word problem having a multiple choice response, A, B, C, D, 4 options. I want you to try the problem and tell me what is the correct answer. You can put it in the comment section. And if you want, you can pause the video and then you can check your answer. The correct answer for this question would come out to be A. And what is the reason behind that? I want you to put it in the comment section. So let's now summarize the concept we learned today, which was all about probabilities of independent and dependent events. In the last video, we clearly saw what is the difference between these two. And in this session today, we looked at the formulas that will help us to compute the probabilities. So the most important takeaway, I'm going to use a highlighter to highlight that here is the probability of A intersection B or probability of A and B occurring together for an independent event is simply the product of the two individual probabilities of the two independent events. However, for the dependent events, the formula is still the same. You are multiplying the two probability and the basic difference here is in the conditional probability and we are multiplying probability B over A or probability of event B given A already occurred. One important takeaway, I'm sure you have observed that in the session today that whenever we have an independent event, we are having a question with replacement so that the probabilities are not getting affected. However, for a dependent event, the word without replacement is your takeaway. If you see in a question that you are not replacing the marble back, you're not putting the ball back in that jar, it shows you that it is a dependent event. So look out for these keywords, especially when you're doing a word problem.